past 4 years running. We have on the order of more than 100% of the growth in wireless subscribers over the past 4 years. We're doing a lot of things right. We have great leadership at T-Mobile. We have a CEO who drops F-bombs all the time. You've seen him talk. If you like that sort of thing, it's a great place to work. We have 14 quarters in a row. We're the fastest LTE network. 17 quarters in a row, we've added more than 1 million customers, sometimes more than 2 million. This latest quarter, we sold 768,000 new subscriptions on the phone side, and that's going to end up being more than 100% of the growth of the entire wireless industry. So if you stack up all the other providers, you're going to bring that number down. So T-Mobile's doing a lot of things right. What are we doing right? If you're not a T-Mobile customer, this is interesting to pay attention to, because we're doing things like ripping up the contracts, letting you use whatever phone you want to use, thanking our customers. Every Tuesday, we have this thing called T-Mobile Tuesday. We give something away. We literally broke Domino's nationwide by giving pizzas away. They basically had to shut down half their stores because we did that. With simple plans, tax included, video streaming included, no data caps, unlimited service. If your provider, if you don't have T-Mobile, if your provider has recently adopted some of these unlimited, some of these patterns, the reason they did it is because of T-Mobile. So even if you're not benefiting directly as a customer, you're benefiting as a non-customer as well. So we're really trying to drive change in the industry. And that's putting a lot of pressure on us within T-Mobile. We have to work really hard. I guess most of us like that, right? And so we have a lot of last-minute requests, changes that when we see a market opportunity, we jump to it. We mobilize lots of people to get that done. And where we are, this group of people you see here tonight from T-Mobile, we're called the T-Mobile Cloud Center of Excellence. And for all those people who work at small companies and not used to big company terminology and the way you name groups, you could work at T-Mobile. Just think every day you could go to work thinking, I'm excellent. Because you're working for the Cloud Center of Excellence. So that's a naming thing with inside big companies. So we think that every day we're excellent. We manage, as a central team, we manage all of our cloud infrastructure. We're about, spend-wise, we're about 85% on AWS and about 15% on Azure. We've been on AWS for 4 years. It's where we started. All of our large projects are there. And our team does everything from help other internal application teams get up and get started on the web to bringing them along to help them get to a state where they're self-service and they can run everything themselves. And we either do it for them the first time, but by the second and third times we make sure they know how to do everything. And we're trying to drive technology changes, we're trying to drive automation, and you'll see today a lot of demos around what we're going to do for automation and containerization. I didn't introduce myself, did I? Or you? Where are you? Or no. My name's Tom McCann. I manage part of the team in the Cloud Center of Excellence. This is Amrith. This is Yogesh over here. He's a primary developer of the platform that we're talking about. And Vinod's sitting right here. He helps us get out of jams when we have disasters. Let's go next. So, talking about the benefits of containers to this group is probably something you're already familiar with. We built this slide and we were really happy and really proud of it. Then we showed it to the PowerPoint experts and they told us, you're not learning anything from this slide. There's too much up here, right? So we don't get to talk about, I guess they were right. Yeah. There's too many things on the slide. We've learned since we're only allowed to have 6 things in the slide. You have to process this slide. Your brain goes crazy. Yeah. So we can't talk about multi-tenancy or code pipeline management or app isolation, security, all those great things you get from Docker. Can't talk about those. Can't talk about blue-green deployment or service discovery or quick rollbacks. We can't talk about those because you're not gonna remember that. And you're not gonna remember if we talk about autoscaler, which we do, which is really cool, by the way. I can show you our CloudWatch graphs, how we autoscale our infrastructure underneath our container platform. But we're not gonna talk about that. We can only talk about 1.5 things. So half thing we're gonna talk about is server utilization. And I don't know what happened with the fonts on this slide, but they're wrapping wrong. The main thing we're going to talk about today is telemetry. When you're building a distributed system, the most important thing you can do is make your system observable. For us, that means making sure that every container, every component of the system emits metrics that we can graph and we can watch and we can set alerts and we can have some particular action on. And so when we talk about, you'll see demos, what we're going to do is we're going to connect in, hopefully this goes right, we're going to connect live to our production systems and look at our staging environment. I'm going to walk through all the components of the system so you can see them. And so it's a little bit daring, but we're ready to do it and show you all that. Talk about where we came from. So we know about all those benefits of containers. From our perspective, as a team that's managing applications, our team talks about customers. We're talking about internal folks at T-Mobile, internal teams. And a few years back, if you were on our team, you'd have 3, 4, 5 different workloads. Each workload team that came in would be its own infrastructure. There'd be some differences between them maybe, but largely at a big picture level, they're largely the same. There's ELPs, there's a web stack, there's some component that might be different, and then there's some state that you're managing, but overall, they look a lot the same. When you build on containers, you can combine that infrastructure so that you can actually normalize the infrastructure, build one platform, one set of infrastructure, and share that across multiple applications. That's the thing we've achieved. We started this in the fall of 2014, where we had, if you're an Amazon customer, you know about RIs, and you know that they're evil. RIs are evil because every once in a while you end up with some RIs that you're not using, especially if you're a big customer. And so we had these RIs that we weren't using, so what do we do with it? Let's try to put a cluster together and do some analytics on those. So we grabbed Mesos, which was then state-of-the-art on the cluster management, and we ran some Spark jobs on this. And then that flowed into early 2015. We did a few more there. We set up some Spark clusters. Yogesh set up some Spark clusters, and we started to dabble in. And then other teams started looking at containers, building container infrastructures.
Sorry to interrupt your
Sure.
idea, but what's an RI, just for everybody
Oh,
else?
sorry. I thought you would know that. Amazon has something called a reserved instance. It's where you prepay for a year for the instance, and in return you get a huge discount, like 30%. But the trick is if you don't use the whole thing the whole year, that can go to waste. So if you use it for 8 months, it breaks even. But past that point, you want to be able to use it the whole year. That's where you're getting your value from that. But if you take the machines and turn them down, you're still paying for the machines. In fact, you're not using them. So we had some extra capacity for a while. So, thanks. Anyone has questions, just feel free to interrupt as we go. As we normalize our infrastructure, we saw the fact that you can imagine here, one of the other aspects is when you're building these different infrastructures for different teams, we have different people working with different teams as well. So we're able to reduce down the number of people it takes to handle all that. So we're saving on labor, we're saving on hosting costs, infrastructure sprawl. software licensing costs, there's less instances to manage, reduced operations. Like, for example, one of the big things is we patch every system that we have in the cloud every quarter. With the container platform, we only need to do that on a small number of machines, and the containers on top get the benefit of that patching cycle for security. So, and talking about our roadmap and our experience with containerization, when you get to a certain scale with containers, you need some system to orchestrate those containers. And so to walk you through what our environment looks like right now, we use Mesos as our container orchestration platform. We use a tool called Marathon to actually run the containers and distribute those containers across all the instances below. And we've set up right now 5 different clusters that we use in the cloud container platform. You can see that we're very creative people the way we named our platform. We like descriptive names. So when we started looking at how we're going to manage clusters, we didn't want to have too many clusters because then you lose the benefits of consolidating all your infrastructure. So now we start with a dev one, which is just our own environment that we use for the next versions of Mesos and make sure those are ready. The non-prod, which is the biggest one right now. We run all our builds out of our non-prod. We've just recently launched a perf lab as well. And that's an important point here. If you think back to the past slide, the perf lab, when we had all those different environments, all those teams that had their specific environments, each one of them would install their own perf lab. And that gets really expensive because those machines are actually need big, beefy machines to create performance. If you're trying to simulate load on your system, so they're creating a lot of traffic, they're using fairly big machines. So in this environment, with a containerized environment, we can build one perf lab, and then all the apps on top can use that perf lab. So it's just another dimension of how consolidating makes our job easier. It costs less money, and just less surface area for things to go wrong. We have different production environments. Normally you see a staging in a dev environment, but we have multiple different production environments for different reasons. We have various levels of security that we distribute our production environments. For example, PCI applications are segmented into one environment. Some stats, again, looks like this font stuff is not working on these screens. But we're right now in our environment, we have 180 containers running in a production environment. In our non-prod environment, which we treat like a production environment, we have 400 containers. These are the steady state containers, meaning they're running all the time. The ephemeral containers that just start, like there's a build. Those containers, we have about 200 to 500 of those containers per day. So they'll just launch for a few minutes, a few hours, and then they'll shut down, which is another great benefit of being on containers. They launch quickly. Right now, our target density is around 8 containers per VM, and we're running about 3.7, and that's somewhat intentional. We want to go slow as we increase the number of containers, so that we want to make sure that containers aren't interfering with each other. We really look at the behavior of the system as a whole as we add more containers. We're actually using smaller instance types right now underneath our platform so that we can get a good sense and get some good learning around what density really means and how high can we go. So by the end of this year, we think we'll have 8 containers per VM. Customer traffic, we're seeing. Sorry about the slides there, but Right now, we have about 125 TPS in this system. We've just done some recent performance tests, up to 500 transactions per second. We're seeing 10 million requests per day, or per day, yeah. And that's at a rate of 2.5 billion per year right now. And we expect to see this grow rapidly. That's one of the things. We've reached a point at T-Mobile where the adoption of containers has just kind of hit the hockey stick curve. And we're just going to be ramping that up quite fast over the next year, so we should see that. One of the big targets for us for the container is to make sure we built a stable platform. And in 5 days, we're going to knock on wood, we will finish 1 year with 0-minute downtime on our production platform. I'll talk about that. I think one question I know that's generally on everyone's mind is, which container orchestration platform should I use? Kubernetes or Mesos or ECS. And I know we've reached a point of hype in this, because I was at my son's birthday party on Saturday, and this guy comes up and says, "What do you do?" And I said, "Well, I work in the cloud." And he says, "Oh, you must use Kubernetes." I said, "Do you know what Kubernetes is?" No. So we've reached that point, right? People are wondering how what we do have opinions on that, one of the key things for us right now is we're seeing great stability out of the platform that we have, and we have lots of different types of applications running on top of the platform. We have mostly we're a Java shop, so Spring Boot, and so we see a lot of Java applications, microservices. Microservices is where we start, but we have some legacy applications are now starting to containerize. That's kind of the next step. So we see people just containerizing legacy applications. We actually have one application that uses .NET Core running on Linux in a container. That's awesome. I mean, that's the world we're in. That's just, if you get that, it's just really cool that we can do that. Just a wide diversity of applications running on top of the platform, applications serving customer needs, applications serving big data, just a large variety. This is what the components of our system look like. Primarily today, everything that's in the left 3 columns we're going to demonstrate. So I'm not going to talk too much about that, but know that when we launch on our environment, everything we do is automated. We have a CI/CD platform that looks a lot like everyone else's CI/CD platform, all completely automated on Jenkins, Bitbucket. Artifactory we use for our Docker registry, and we use that because it's one central repository for both Docker containers and other artifacts. So it works out pretty nicely. And we use a variety of different config management tools, Puppet. We actually have Chef internally and Ansible as well. So like every large organization, we have a little bit of everything. So with that, we're going to go ahead and hopefully we have a good connection here. And we're going to take a live look at our system. As I said, the one thing I think we want to leave you with is telemetry. It's really important when you're building these distributed applications to make sure you have good telemetry around. So what we're looking at here, so we build, Amrit, you need to start talking at some point. I'm getting tired. So what we're looking at is our environment. The tools we use for monitoring, the stack we use is Grafana is our visualization layer. Underneath that, we have 2 different sources of the data. We have Carbon Cache and we have Prometheus. Making the transition to Prometheus as we speak. And you can see the whole infrastructure right here. The Mesos masters here, they organize the cluster. You can see the agents were in an unhealthy state, which means there must be a disaster of some sort, right? Oh my God, the node. What's going on here? There's a disaster. I think we need to actually maybe do some disaster recovery. So what's happening and what we're seeing here is the entire infrastructure we're running in AWS in US West in Oregon. What we're going to do right now is we're going to replicate that entire infrastructure and point it to the east in AWS, and we're going to refresh it all. We're going to start that process. It's going to take a little while. Somebody time us. Is it? 6:51, right? Let's see how long it takes us to refresh. Bring up all the infrastructure. So what's going on now, we're going to bring up the entire infrastructure, all the instances, and all the applications, containers that are on top of that.
So this is actually quite powerful. If you ask me. You can hear me right in this? Or?
Yeah. So actually this is quite powerful. Like earlier we used to take about, so actually this happened live for us. One of our AWS direct connects went down and our entire west region went out of connectivity and we have to fall back on the east. So at that point of time people are asking like, how much time do you take to build an entire cluster? So my answer to that was it would take around 6 hours, which is, it sucks. So so then we came up with a plan of actually, you shouldn't take 6 hours, you should actually have a time, like within like 10-15 minutes, you have to build up an entire cluster. And what you're seeing here right now is it's building the entire Mesos master, and like 10 of autoscaling groups with autoscaling. And it's actually deploying, installing Mesos, Marathon, Consul, Zookeeper, a whole bunch of stuff. And it creates a load balancer and all those things. And from Route 53, you can have the DNS fallback and failover and all those things. So this script actually usually takes about 7 minutes to launch an entire cluster, which is down from 6 hours, which is quite great.
Is CloudFormation you're launching on?
No, oh, that's a good question. So this is Terraform.
Terraform, thank you.
So we use Terraform for launching the central cluster. So including the load balancers and every single thing is on Terraform. So it is cloud agnostic, so we can use it for launching on Azure if you want to, any other platforms you can need. So so this one, change the screen. Yeah, so this is going to take, yes.
Could you talk for a moment about what it is that's replicated? I imagine you have some saved state, as well as new incoming connections would then be routed over to the East Coast.
Yeah, so so as I told before, you have the Route 53 that's doing the DNS, like latency failover, or you can have geographical failover and all. So you have the platform that will be both on the west and the east. So when it actually fails on the west, now the Route 53 would actually know that okay, there's a failover there, that you don't have any live containers that can serve traffic. So it would actually keep pinging for the east region also to come up. It would roughly take about 22 minutes at max for us to bring up the entire cluster with the containers running. So what you can actually see here is not just a platform coming up, but actually every single container that's running on the west region also getting replicated on the east. So, and then you can see the traffic coming in and serving up the customers. So this is actually better than the active-passive model, where actually you have a cluster running as passive or a stop state or something. But at this point of time, it's actually bringing up the entire cluster right from scratch. So you don't have any instance running, you don't have anything, it's right from scratch. Did I answer the question?
A little bit. One might imagine some saved state in a database somewhere.
Oh yeah,
like
so
company
database,
names.
yeah. So there are two types of things. One is that if the cluster fails, then you still have those databases and everything, you still have the connectivity and stuff. Most of our databases we use RDS, so we assume Amazon is going to take care of those. And we also have some with Oracle, where we use Oracle building gateway replicates between East and West region, and the DNS again on the Route 53, so you have the connectivity set apart. So most of the containers are like stateless, so that's when it's going to be easy for us.
a question here. If you're not using active passive model, are you going to have some downtime while you're replicating the clusters?
Yeah, so even in an active passive, time taken for you to start up those instances and come up with it. If you're running on active, it's like, yeah, immediately you're going to get activity, right? But even an active passive model, you're going to start those containers and then, start those instances and do it. So this is what we felt is like, this is much better way of bringing it right from scratch, because we have tested it like over and over again, and it's quite powerful.
And the one advantage you're having this is non-protection by not using the compute instances.
Yes. Yes.
So we can walk through. We can walk through the entire infrastructure so you can see at depth everything that's going on in the system. You can see in this cluster. Now we have multiple clusters. We're looking at one. We're looking at our staging cluster. You can see the master is currently master 2, which is in which region?
It's everything on the west region, but one of the
Which AZ is what I meant?
Oh, it's AZ2.
Yeah. Okay. And so these other ones are running. So this is running over multiple AZs within Amazon. So each master, if an AZ went down, we'd still be able to recover that within the staging environment. You can see the other components of the system. Marathon will walk in. We'll show you a little demo of that later. Zookeeper, which keeps the masters, keeps the masters in the sync. HA proxy is the component we use for traffic, and consoles we use for service discovery. This part is actually Splunk, which actually exists on-prem for T-Mobile. So we're connecting our network, our cloud is part of our internal network as well. We have direct connects through Amazon, so we're able to connect back into our systems of record and have our logging information installed there. And so anyone who's adopting this platform automatically gets Splunk, automatically get these dashboards for their own application.
There's a whole bunch of when Tom was talking about traditional applications, they go and deploy. They're like for every single application you have to go and build monitoring, you have to go and build Splunk integration and a whole bunch of stuff. So what we decided is like it should be self-service. It's like BYOD, bring your own Docker. That's the only thing what application team has to worry about. They should not worry about telemetry. They should not worry about like security scans and all those things, because we are trying to add everything to the Docker images, and we can do all the heavy thing. So once you have it, you go and deploy on this particular platform. You have it, so you don't have to worry about all this stuff.
So you notice that we started our DR, but I don't know if we've done any investigation on this problem yet.
Okay,
Do we know what's going
check.
on? Are you fixing it?
Yeah, it's deployed.
Oh, the DR is deployed already? Is that 7 minutes? 8 minutes? It's almost deployed.
Yeah. It's coming up. Oh, wait a minute.
So our target was 30 minutes, and right now we're log in. What you're seeing right now is Marathon, and Marathon is the tool that actually deploys the containers, so a developer can go and actually see. These are the applications that are running at the top. Each application has its own folder. We're logged on as an admin on Marathon, so we can see all the applications. But if you're an application developer on your system, you would only see the applications that are available to
So
you.
this is like kind of with LDAP. So it's like, since I'm an admin, I can see the entire view. So people can actually have like multiple. For example, I'm going to this particular application. You can have multiple environments with it. So you can consolidate environments. If you go to a staging cluster, we have like some teams have like QA1 to QA10, UA1 to UA10, and it's like you have like 22 environments on the same cluster, and you have like a whole bunch of other applications deployed as well. And it's quite. I mean, if you look at it, it's like one cluster, but having like 20 different environments for different teams. So it's like everything is consolidated, and you can have fine-grained access control to each of them. So if you actually see, it's getting deployed, and some of them are getting deployed and all. So from the script perspective, it has deployed everything, so we can actually see the output, like how many of of them were successfully deployed, how many of them not. So this is actually the production running containers, which we just did a DR, so it just fades over and logs everything. So in less than 10 minutes, you can actually see the 10%.
So what's been done to this point is the infrastructure, the AWS infrastructure. That's the longest piece. It's, setting all the infrastructure up is about 7 minutes. And then the containers, because it's so quick to launch a container, would be a couple minutes. So let's dive in. So if you can see here, in this environment, we have 273 containers running on 52. The agent in Mesos speak is a virtual machine that is a host for containers. So that number of containers running across that number of machines. We can see the total amount of memory across all those machines. Mesos pools all the memory, pools all the disk, and the CPUs. So we have somewhere around 390 or so CPUs that are available to a whole pool of applications running here. And we can see the disk utilization for each agent. Again, an agent's a machine that hosts containers. And we can see the disk percentage, each agent's individual CPU utilization. The CPU utilization in our non-prod environment is a little lower because we're with non-prod, we have a lot of stuff running there, a lot of environments, a lot of test environments. But we get that densification even in non-prod environment. So let's go back up. So now we're looking at, if we just clicked on the agents.
Oh, actually, again, you're down here, so just wanted to show the picture.
That's okay. Just I like this model better.
Okay. Yeah. So
But
this is the exact same thing.
did you fix something? It's fixed now?
Yeah.
Okay, so we don't have a disaster.
Yeah, that's right.
Okay. So if you go back to the main screen, if we refresh, so this guy should turn green.
Yeah. So it's fixed.
So that happens all the time. He's saving us all the time. So that's just, so when we missed one piece there, we wanted to show what happens when something like this happens.
Should I show the Slack channel?
Yeah, we need to go on the Slack channel. What happens here when we see some environment happening again, this is our staging environment, you'll see something happened here, some alert fired, it went into our Slack, in our Slack channel. And so we have teams here in Bellevue, down in Dallas, and in India, looking at this around the clock. And so we're responding to each.
So we get both email notifications, we get Slack notifications, and we also integrated with different webhooks that will go to different channels. So we have like all sort of alerting and monitoring that is made for this.
Yeah. So So he commented in the Slack group, and now he's alerted the team that the agents and everything's back healthy again. So here you can see, if we just want to focus on the agents and we need the detailed dive just on the agents, we can see which agent has the most tasks running. We can see the agents with the highest CPU utilization. And so this now, we're looking at the pool of machines that serves all the containers. The total aggregate network throughput. So here you can see Grafana has a capability, if you don't use Grafana, or if you use an old version, version 4.1 introduced the ability to set notifications right from here. And so you can see now that this is green. At one point it was red, and that's what triggered the alert, and that's what triggered the other thing to go.
This is a master.
Okay. Yeah. Okay. So now we're looking at the masters. Masters are generally uninteresting unless something goes wrong, because they don't do a whole lot of work. In other words, no applications run on the masters. If the masters were to entirely go down, that wouldn't actually affect the applications that are running. It would affect new applications that are on board, so the agents would still run until your masters came back up and running again. So.
Huge dashboard.
Yeah.
So this is one of our favorite dashboards. So this is going to give us a whole bunch of information. So what you see is currently there's 430 containers that's running. That's inclusive of all of our dev, PLAB, and staging. And actually you can see is it keep going up and down. People keep deploying left, right, and center, and you can see them going up and down every second. So it's a huge cluster. We have like 88 agents, and we have like over 17 applications deployed. This count, what you see is the number of tasks completed. It's actually crossed more than 80,000, but it's like it got reset. And you have available, so CPU utilization is 87%. What it means is like it is the available CPU available for containers to go and deploy. It's not the CPU percentage in each instances, it's actually the number of CPUs available in the Mesos cluster. So we intentionally kept it high. So we have auto scaling in this. Actually, if you scroll down, you can actually see the auto scaling, just the utilization. So we have kept the low as 75%, and it will trigger a new instance if it reaches 90. And so that, I mean, end of the day is like you're paying a lot of money for getting those instances, and we want to better use it.
So you're saying that low being 75, that you're turning down instances?
Yeah, if it goes below 75, it would actually terminate one instance and wait for like 600 seconds, and then it'll see again if it is 75%, it'll again reduce. And if it's more than 90%, then it'll keep reducing. So typically it takes about like 5 to 7 minutes for an instance to come up. So it's like, and by then we'll have like, it's already, you can see there are like 29 CPUs available. You can actually probably even deploy 29 in minimum, or you can deploy like hundreds of them if you're using just 0.1 CPUs. And you can actually see the number of containers per application, the number of containers running per agent. Actually, the density what Tom was talking about, 3.7, in some of them, 14 containers are running. So you can see them right here, the containers running per agent. And you can see a whole bunch of metrics like the CPU usage, the memory. All of them is Docker statistics. It's not the JVM memory, so it is the Docker statistics. The container least usage, and a whole bunch of these informations right here. You can actually get the CPU consumption by the top container. So yeah.
Can you talk a little bit about how you selected instance types for performance costing, and how you changed that strategy over time as Amazon changed
That's a very good question. So, maybe you want to take it?
Yeah, so it depends on the workload. As Tom mentioned, we use RI. And the best thing about the cluster environment is you can have a like a hybrid model. So you can have a 4-core machine, you can have 64 machine. And it depends on sometimes applications, if you have IO intensive applications versus throughput applications. So cluster, I would say, is kind of hybrid, but we have multiple auto-scaling groups, and depending on what kind of application you have, you kind of deploy within that auto-scaling group.
So within a single cluster, you have different classes and capabilities, you're scaling that.
Okay, let's want to make sure, how are we doing on time, Rip?
We got about 5 more minutes.
Okay.
Yeah,
Okay.
that's good. A little bit over it.
Alright, so let's rip through the next, this is,
Yeah.
so,
We have some QA time there, Tom.
yeah. This is, really proud of this. This is, really proud of this. This is the monitoring stack on top. So one of the things we were going to show 5 minutes, but one of the things we do, which is really interesting, is we monitor our monitoring.
Yeah, we have to.
Yeah, right. And that's come in handy a number of times. When we're monitoring our monitoring, you can see that the monitoring system just was 80% full. And that thing shot out into Slack and was like, knock, 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 is anyone there? Please, let's not have our monitoring system go down, because then we'll lose the visibility into the system that we have. So it might seem kind of weird to say you should monitor your monitoring system, but you have to, because that's where you get your leading indicators that something might be wrong. Your monitoring system's not helping.
Also, the important thing is pretty much every component that we have is containerized.
Yes. That's a very powerful thing, yeah. Or Grafana is containerized. Prometheus is containerized. Carbon Relay, Carbon Dash is containerized.
HA proxy.
HA proxy is containerized, yes. So everything is containerized. So it's highly available, so Marathon is going to.
So that's what enabled us to launch that new environment in the East in 10 minutes.
Yeah.
Is the fact that every single component of the system is containerized. This monitoring system itself is containerized, and just want you to see. We're looking at a live view of the universal monitoring system, and this is the infrastructure where you have Grafana, using Prometheus, an ELB to manage multiple instances of Prometheus, and a bunch of collectors and surveyors out there. So this But if something were to go wrong in this screen, it would change color. So we can see the system live and see multiple components of the system. Let's keep going forward. HA proxy.
So,
HA proxy is a key component. So you can see this is actually where everything enters into the system.
so one thing which we added here is what you talk about is self-service, where you just need to come and deploy your containers. But what you see here is the list of applications that is being deployed. So an application team can come and just choose which application they want, and they will see the live metrics here automatically. That the same goes with container statistics. So different applications, they can come and sort by different teams, and they can come and do it. This is very useful and saves us a lot of time. Like when there's issues, they don't have to come to us and say, okay, what is my utilization, when the issue happened, and give me the history of information and all that stuff, because this gives everything, whatever the application team needs. And they don't have to come to us, and all in terms of production issues and all like this. It's very, very useful. Due to lack of time, we just try to keep going. This is again while debugging the issues. It actually shows you per container, per instance level, what are the containers that's run now, per previous hour and over a period of time. And you can see the CPU, memory, and the network usage for those. And this is the server statistics. So just want to get into like disk, memory, and all those actual raw metrics of that instance, you can actually get a whole bunch of these information. This is really useful when an instance is having some sort of issue. This is kind of one of an amazing dashboard. So our Jenkins task is also containerized. So every single build that's getting triggered is running as a container. And the container lives for a period of, we can get like 3 hours or 6 hours, and it keeps taking a number of builds, and it terminates as soon as the build is done. So you can actually see some have been running for some 3 minutes. There's some backup job that is running as container. It saves us a lot of money in terms of better resource utilization. We don't need to have a dedicated Jenkins slave. That's the usual thing that you have Jenkins. Once you have a Jenkins slave, now you have to pay for the Jenkins slave. You don't have to do that. Now you run in this Mesos cluster, and you're running it free of cost. Because you already have those clusters available, you have some sort of resources available, you just run it on this. It's pretty cool.
So do we have the self-service dashboard in Grafana?
Oh, this is a self-service dashboard.
So this is for the application?
Yeah, this is for the application team. They can actually come and choose the different. Yeah, we don't have time to get into the details.
So the point there is a lot of what you've been seeing is stuff that we can see, but if you're an application developer, what can you see? Just by launching an application without doing anything on our platform, our customer, our internal teams will get a similar view where they can look at just their application, the metrics for just their application. So that's another important component of what we're doing. This is interesting for us. This is we use this as the raw data for charging back those customers. Because one of the key tenets for us as a cloud team is to make sure we manage our spend well. And so one of the things that makes it a little more difficult with containers is getting that granularity of who's using what. You get a lot of that information from AWS through tags for the underlying instances, but now that you're having containers inside it, you need to find some way to get that data out so you can determine who's spending what, who's using what resources. So this gives us the raw
So this actually
data.
is 2 different classifications, like actual and provision. So a team can request for like 1 CPU and end up using 4 CPUs. So, or they can ask for like 10 gig of memory and can use like 30 gig of memory. So you can actually get both, and we take the max out of those, and then we calculate the billing. So that's how we actually calculate the billing and charge back to our customers. So it's like you just bring your Docker, you just deploy your instances. We know how much cost it is. Just calculate based on the AWS. That's how AWS charges, right? So that's the same thing we're doing to our customers.
And then we use that difference. We use that difference between what they said they're going to spend and what they're spending. We use that for beer money. The last thing we want to show you. Okay, we saw the billing. Last thing we want to show you a completely different view of this, and this is a high-level service health dashboard. This is something really new for us. So this gives you. So what you've seen so far is really interesting for the teams that are working supporting the container platform itself and all the dynamics that we can monitor. But this component actually allows us to go in we look at the staging environment.
Yeah, it is a good speed up. So actually you can see there's infra components and there's application components. Infra components is actually the cloud container platform which we built. So we have the different components, it gives us the status of each of those. And actually, if you come down, you can actually see the application level components of different applications that's been deployed, and it shows us the recent events, it shows remaining services. It's like similar to the status page of AWS. You can actually see the show metrics like why it has failed, and there is also a login feature where users can go and add information to this. This is very powerful in releases or any of those times when this will be a single place where teams can come and check. What is the services? Is it a problem with the platform? Is it a problem with the services? And when did it happen and all? So you can actually go to the history and you can see the previous instances when the services went down and all those information. Primarily is like code warning, error, and all sort of information. You can actually see most of these are running fine. There's one more feature called the search. So you can actually search by application. For example, you just want to rem as a service, you can actually search by that. You can search by application. So this is being built from scratch by T-Mobile. Yeah.
So,
No, sorry, that question was.
And if you have the time, so I love all the ops stuff, I think that's awesome. If you have the time, I would love to hear what the adoption process has been like from the dev side. So you went from clusters to containerized systems, permanent Java shop. How did you get your devs into the container world? What was that uptake like, and what's their experience like now?
yeah, that's a really good question. I think just to repeat that, I'll repeat that question. It was asking about adoption, and look from the developer point of view, how's adoption been with developers getting traction on this platform? It's a really good question because it peeks into the broad array of developers that we have internally. Some that have been itching for this for quite some time, right? They had that first year T-shirt at the Docker meetup, and have been looking for a platform like this for quite some time. So those were some of our early adopters. And so our growth rate, we showed you, we have like 2 billion transactions per year. Most of that's in the last 5 months, right? So we have, so like I said, we hit that hockey stick curve. We had some early adopters, and now it's hard for an organization of our size. We have 1,300 people in our IT department. To get everyone on that page is, it takes a while. So there are other clusters running within T-Mobile. So some folks that went off on their own. The key thing that we've done is we made this one multi-tenant, and as opposed to just someone worrying about their own cluster. And so we went out, we saw some opportunities for folks that were willing to try it. We went live with a production literally almost a year ago this week. And since then, we've been working with teams to kind of get them ready. The first couple of teams that started using it had a little bit of learning curve. Once they got it, they started telling other developers how to do it. We've done a lot of internal, like full-day sessions on how to get up and running on it, and now it's just getting its own traction. Now we're trying to manage the other problem, which is people coming in fast enough they want to get on the product.
I think a key point for adoption is when you tell people what they have to do the old way, the IaaS, like here's your checklist for operational readiness to be allowed to go to production in the old path, and they look at that big giant long list compared to what they get for free here, it kind of becomes a no-brainer in terms of which path they want to go down.
Quick question in the back?
Yeah, so after a year, what percentage of your potential user base do you have on the platform?
This is another good question. He's like, we've been running for a year. What percentage of our user base is on here? So give you some kind of scale there. We have about roughly 40 applications, what we call workloads, on the cloud. And that's somewhere around 15% of the total T-Mobile workloads. So that gives you a sense for where we are on the cloud in general versus on-prem. And where we are on CCP, about 13, 14 applications have at some level dipped the toes. There are some applications that started. We have about 5 applications that have just started ground zero, born on the cloud container platform. The rest are starting to move pieces over. So it's a typical microservices strategy where you take some component of your monolith, you make that a microservice, and you go there and you start to move down the path. That kind of leads to some other questions like what's next, and what's next in the container world. For us today, everything that we have on here, most of what we have on here, correct me, is stateless. We don't today run our Cassandra rings in the container platform or any other databases or things like that. We do have some things that are kind of smaller scale that have state in our container platform, but mostly it's just the stateless component at this point. So we see we see scale as a primary next thing that we need to worry about. We think we have a better level of security with containerization than we did before, because you're able to lower the scope of the surface area, if you will, and have a more tightly controlled environment where you can control the container types coming in. But we see lots of opportunity for improvements in security, storage, and just continuing to get better at operations. And we're saying 0 minutes for a year, and we really do want to knock on wood to make that. But we know when we say something like that, we really risk tempting fate. So we really have to be up the game as we kind of get scale. We're going to get more systems on this.
Thank you.
So you mentioned storage just now. Oh,
Actually, I'm sorry, we kind of ran a little bit on time here, so are you folks pretty much done?
Yeah, so
Yeah,
are we
we're
done?
done.
We just, last time, all I wanted to show was the
Can we just
structure.
hold
Very
this 5 minutes?
Yeah.
Stick around afterwards. I don't want to keep
We got
everybody
the
here
next
for
round.
today, so please.
Okay, just the last one, we're going to just try this entire cluster of people now. Just a discussion.
Do you guys want to set up for?
We're going to take a little break. So
Oh, okay, we'll take a break.
You guys can carry on.
Okay.
Yeah, sorry, I just don't want to get bogged down in questions. Let's do the rest of the presentation.
Yeah, so.
While that's built, maybe I can shout out a quick question, which may be
Yeah.
relevant.
Let's hold the questions. We'll go to break. Just a quick wrap. We'll just wrap up. I think you've seen our progression in containerization. As a customer, we have a specific viewpoint on the whole containerization thing, and we're excited about where it's going. We're excited about the opportunities for T-Mobile. And the one thing I hadn't mentioned that I should have mentioned is we're hiring. All right, thank you.
So just real quick, and I apologize, questions are always welcome. I just don't want to hear all night. So thank you, Tom, Amrit, rest of the team, folks. So we're going to take a break for 5 minutes, and then we convene and get started with our second one.
If you haven't signed the sheet over there,
I'm going to get Tom in trouble because I actually have
Yeah, that's
Oh, really? Maybe it's because I'm invited because I believe Jeff is a guy who is hired at the beginning and said dedicated 6 pages. That's good enough for me, right? So, it's still a deck, but it's a 6 pages.
Like my daughter who
Does she? I used to work in these buildings. That's when you have all 435. But dev feed to dev shop feed, right?
So your switch.
Yeah, I got the resin IL guy. I got this like. All right, good seeing you, sis. All right, the lighting. Good seeing you again. Yeah. Great presentation, Tom. Good to meet you. Good job.
Awesome, great. All right, well, first of all, welcome. For you get a chance to kind of kick this thing on the right foot here. A lot of logistics going on. Appreciate everybody coming in this evening. I know it's a wonderful day outside. Really good turnout. Just out of curiosity, how many people are brand new to the meetup for the first time? Quite a few. All right. So we'll try to get these organized every couple of weeks, 4 to 6 weeks. We do tend to move around a little bit, but there'll be more fun talks coming here. And FYI, Tiffany, my wonderful co-organizer. You can thank him for the boost. Yes.
And of course the speakers.
Thank you.
Global and
All right, awesome. So speaking of speakers, we've got Brian and Petros next from resin.io, talking about Docker and IoT and the embedded world.
All right, thank you. So I'm Brian Hale at Resin. Is this too loud or should I pull it? I didn't even figure that out.
Sorry.
Should I rotate it? Yeah, I don't know if we want to do that. Anyway, I'll talk very descriptively. Brian Hale from resin.io. I'm joined by Petros, our CTO, and Allison, who heads up product marketing and strategy for us. Thanks for having us. The T-Mobile folks said they would not sell you on anything. We will sell resin really hard. Subtly, and we'll mix it in. But we will ideally open up your worlds a little bit. Most folks here, I assume, think of themselves as cloud or web developers, generally speaking, and we are here to convince you that there is a really big world outside the data center, and it's waiting for you. I'll explain a little bit more as we go. So a quick overview on Resin. I promise we'll keep it short and light and friendly. Our mission at resin.io is to take all of the luxuries that you folks primarily enjoy. You may not realize it, but you've got fast provisioning, you've got CI, CD, we've got great monitoring tools, alerts, and all these fun new toys that are developed in the last 5 or 10 years to make your lives wonderful. And meanwhile, folks that are building, don't take offense, real products, physical products out in the world, connected online, embedded developers, you might call them, are stuck in the dark ages. They live in like 1985. They hopped in the DeLorean and have been stuck there for decades, right? Generations of technology infrastructure basically left them behind. And our mission is to allow those folks, product owners in particular, to be successful building, deploying, managing products at scale. And it turns out a lot of those bottlenecks are around software, and it turns out Docker, spoiler alert, has, we think, a pretty nice place in that world. Super high level overview on the company. Notionally, we're based in Seattle, but most of the company is distributed far beyond Seattle. We've got an office in London, one in Athens, portions of the development team are all over the place. I could list off all the countries, but we'd be here for quite a while. 50 people, mostly all developers, or folks that occasionally pretend to be one, like myself today. And then this is what's I think most interesting. And for me, I came from the cloud and web world. I spent 6 years at Chef prior to joining Resin. There's a really, really big, fun diversity of use cases out there. In my prior life, it was exciting and fun, but everything was ultimately boiled down to an end-tier wedding. And we've got some really great things happening within our customer base. All right, I'll be quick with this, but this is sort of a fun way to introduce the problem. And I'm a huge sucker for a good founding story. I'm not a founder of the company, but I strongly associate with where Resin came from. So this is August 2012. Many folks may recognize this. This is the Mars rover. A story that is not often told enough about the Mars rover is that once that thing landed after, I think, no, don't fact check me too hard, but it's like a 2.5-year journey to travel hundreds of millions of miles. it lands, and it sits there for several hours, just motionless. And it turns out what it was doing over the course of several hours was a software deployment. So the Mars rover didn't have enough onboard storage, this is 2012, remind you, to house both the software that was going to navigate its way down to the surface of Mars, the landing software, but also the navigational software for the rover itself once it was going to depart. And what this also allowed the developers at NASA to do was to iterate on that software in flight. So they were on like version 11 of the code or something. They had 2.5 years to improve upon this, and they had a test environment rigged up wherever Cape Canaveral. And so they were performing this very, very complex, very, very high-stakes software deployment over the air in more ways than one, and it was successful. And around that same time, in London, leading up to the Summer Olympics, a team of PhDs with computers and computer science, like really, really smart folks, they thought, had another project with much humbler roots. What you see here is the world's most expensive over-engineered trash bin. So I think they were like, well, you know better than I do. 200 of them.
100 of them. Yeah, 100.
But they were like $40,000 or something like that. And this was leading up to the Summer Games in London. And these things had, they're bomb resistant, and then they had digital displays on them that were going to show all sorts of wonderful content and advertisements and various other things. It was actually like a reasonably sized civic initiative. And this team, which, as I mentioned, were really, really smart folks, through a series of events, had to take ownership, not just of the software, which they originally were tasked with building software, but all of a sudden they had to take really ownership over the health and well-being of these devices. And they thought, all right, how hard can this be, right? We're in an urban environment, we got good connectivity, it's like an i7, i5 processor, like you can run a real browser, this thing's like beefy, beefy server, right? Easy. And I don't know, within a few weeks, a few days of taking ownership of these things, they're just bricking devices left and right. It got so bad that they had to walk around the city, finding the devices, nursing them back to health. It got so bad they actually deployed a traveling salesman algorithm to have them walk to the devices most efficiently. I think this setup here is in front of some pub. You can see that Paige, one of the co-founders, it's in winter obviously, so the gloves on, there's pictures of the snow. He's sitting in front of his pub. They took a chair out of the pub. He's sitting down here, he's running commands, trying to nurse this thing back to health. And at some point, and this is why I think it's a great founding story, like it came from this huge level of angst. At some point, they thought, wait a minute, like we can get push code to our servers, right? We can get push code to AWS or Cloud Foundry, pre-Cloud Foundry, Heroku. Like why can't we do this? Why, when it's time to manage these like a couple of measly trash bins in London, are all of a sudden we have to go back, like I said earlier, to the dark ages. And that's where resin came from. And so the team at resin, at that time, this was pre-Docker, they started to kind of unravel what was behind the scenes for all these really popular platforms as service offerings. And the answer was Linux containers. And essentially the punchline for this presentation is, look, Docker is obviously really popular in most of your worlds, but it's totally wasted on the data center. There are characteristics about Docker and benefits of Docker that you folks, to be honest, don't even care about, or at least like most mainstream cloud web developers, like you don't even think about. But for these types of use cases, it's essential. And it's really the first time you can actually do, let's call it virtualization on embedded devices, right? Because it's low overhead, you get close to the metal, and you can fit them onto these devices. And so, if there's one thing that maybe you folks leave here today with, it's this thought of, wait a minute, maybe 5, 10 years from now, we'll look back on Docker as having the biggest impact outside the data center, because we certainly believe that. All right, so this is a representative set. This is 4 or so of those, I mentioned, kind of 75 plus customers. They're doing really fun things. They're all running Docker. We'll explain exactly how and what's in our sample later on. To hit some of the highlights, we've got tidal turbines off the coast of Australia. We've got underwater drones, which will become more and more autonomous over time through new software deployments. The tidal turbines, by the way, run algorithms on them that will change the pitch and yaw of the blades in order to most effectively generate electricity. And they are constantly revving that algorithm, just like you'd want to rev one sitting in a cloud environment. Oil well rigs in West Texas, largest property owner in New York that plumbs all sorts of data from HVAC systems, security systems, lighting, you have it, and they run analytics on site to determine which things you turn on and off at various times to optimize energy efficiency and cost savings. So all of these things are both software driven today, but increasingly software driven. And the way in which these folks compete, once their product ship, is on the quality of the software, and they want to be able to iterate safely with a lot of visibility and a lot of reliability, just like we all expect to do in the cloud world. You know, I think we actually probably covered this, but like the high level kind of thought process to go through on this is think about an Amazon Web Services instance, and then think about one of the control servers sitting on that tidal turbine off the coast. Right? My Amazon Web Services instance has infinite compute. I can assume infinite bandwidth because it's plugged in by fiber. And I also can design my systems with failure in mind, right? I can treat everything like it's ephemeral microservices, and if something fails, it's no big deal. I can just spin up a new one, as long as I design around that. And it turns out, like we said earlier, Docker is, I hate this word, but it's kind of like a game changer for these environments, right? All of a sudden you take an embedded developer who now, because of the way in which we can implement Docker, and I'll show you this later, can push code to containers sitting above a host operating system with connectivity, so they know that they can push code, and if they push bad code, they're always recoverable. Atomic updates is a big example, right? So a Docker container, when it's deployed, by definition, is never going to be half installed, right? That's nice, I suppose, you know, in a cloud world. Our customers, it's huge, right? Because you never want a device that's really, really far away and really, really critical to be in some sort of an in-between state. So the idea that you can have fully atomic updates with containers is incredibly important for these folks. Am I missing it? That feels like the bulk of it. So we'll talk a little bit through resin, and then we'll show you a demo, and we'll put it through its paces in some of these resilient ways that I was describing. But fundamentally, what runs on it, and it's in some regards it looks like this sort of the software stack is a sort of unholy marriage of embedded technologies and cloud technologies, but this happens to be what we think the future looks like. So working bottom to top, you've got the Yocto Linux Foundation project, the Yocto Linux project, which is to stamp out really, really lightweight host operating systems for different types of hardware. I think we support 25 plus different, mostly Linux-based devices, by the way. So we're talking, Pi, BeagleBone, Nook, Edison, Samsung Arctic, and then invariably a lot of custom devices once you get into bigger accounts with bigger scale. We have some ways, and I'm not going to dive into this because it's not really the subject of the talk, but we also have some ways to display simpler devices. So a lot of our customers will have sensors connected to a gateway, connected to a cloud environment. You can see all of them in resin. You can push code to all of them with resin. But really the management challenges exist of those complex devices that can run some form of embedded. Next to that is a configuration, let's call it, of the Docker container engine. And we'll talk through some of the differences between how we work with Docker and how you might work with it in a cloud environment, and also some things about the future direction there. But it's a configuration of it. And then down at this level is where we keep connectivity in various forms. We have customers who run on everything from 2G networks to Ethernet and everything in between. But the big thing is connectivity is maintained here, and then above that line is container link. And anything that you can do in a Docker container becomes fair game on these types of devices. And it becomes fair game regardless of whether the device is ARM5 or ARM8 or Intel 32 or 64. And you can deploy all sorts of, any of the third-party services or tools that you may want to use, completely fair game. We've got a thin agent that performs some coordination activities as well, fairly important. So far, so good? Questions?
Yeah, in this diagram you have mentioned Docker. Does it run on Docker other applications like CoreOS?
So does it run on other types of host operating systems like CoreOS?
Without Docker.
Without Docker?
No, so our stack needs Docker to run, and we've made our stack run on with the for example, if you have a Docker daemon running there. There are some features that you get if you use Resin OS that like expect integration from that, and that's why you get these features only with Resin OS. So one example is having updates for the host operating system. But Docker is a requirement for the platform.
And really, the only point I tack on that is for most end users with Resin, they're thinking about sort of the base image operating system up above, and on that level, again, pretty much anything you want to do is very handy. Alpine, Debian, handful of those we ship out of the box.
For every device we support, we also supply about 5,000 base images, different configurations. So most of our customers are using Debian-based workloads on these devices, but you can do whatever you want. Even though we use Yocto, most of our customers are using Debian.
How do you make the updates safe?
We'll show you in a minute.
Yeah.
But the question is how do you make the updates safe and recoverable? I don't know if you want to give me a high level on that before we show it.
We can get a quick answer if you are referring to the container updates, if you're referring to the host updates, the answer is no. What are you asking?
So,
Yeah, I mean, container updates, we bring down the new container, make sure everything is synced to this and when we started. So in that regard, you don't really go through a point of a critical point where if it fails, you have a problem. Doing the same thing for the host as you replicate it in the right after.
So when you guys say on device, so you guys actually go ahead and run your operating system on the.
yeah, we'll show you that in a minute. We'll show you that exact activity.
And then I'm assuming that you have ported the entire system to be compatible for the devices, or is it like generalized framework that you have ported and you are running on all of the devices?
So,
Okay, that's good.
yeah.
So for every device, the resonance is specialized. There's a version for Beagle, there's a version for Raspberry Pi, etc. The code for that makes a build is more or less generalized, and that's a benefit we get by using the Yocto project, where it kind of separates what's device specific and what's not device specific. So even though they're specific, it's really easy for us to support a new device.
Which is, and that dynamic's really important in these types of use cases where once a lot of these devices are out in the field, they're there for a long time, right? You can have a device fleet that's got 5, 10, 15, 20 years or more. You're invariably going to have some diversity of hardware, which means diversity of architecture types over time. So the ability to have more or less the same code base you can apply to all, is hugely important.
Just to flip that around, as you move into like a CI/CD model and you're pushing lots of code out to those devices, you get some unique challenges on managing the server side as well. So call it digital shadow, call it digital twin, whatever buzzword you want to call it. The back end has to stay in sync with all these different front end pieces. Is that a unique challenge when your devices are morphing that quickly?
So as far as the device shadow thing you mentioned, that's mostly used when like it's on the application level. So you're gonna run I don't know, some algorithm and you want your shadow in your cloud. We don't really deal with that part.
So that's
our backend tracks the version that every device is running. And so even if you have a device on the shelf for a year and then it comes back online, it will figure out, oh, I'm running version 1, but now there's version 100, and it will sync and catch up with everything else. Yeah.
Did you ever run Linux in the Octo on one device?
So,
Meaning a different flavor of Linux. The Octo is Linux.
so what's
The model looks like you might run them both on one device, like Debian and the Octo on the same device.
Right.
Is that an either or is it static?
No, so the Resin OS is using the Yocto for the base, and then in your container, you could be using Yocto again, you could use Debian, you could use so they're separate.
It's a stack.
I think we talked through a lot of this, but we get a lot of stuff for free once we figured out how to responsibly wield Docker in a lot of these environments. I think we've covered really most of these, right? And we'll show them in demo, so I'm not going to work through these in too great a detail. Maybe the only ones we haven't mentioned would be privileges, which becomes a weird word to see here. But essentially, the way in which we run containers are in a little bit of a mode with some elevated privileges because we need to be able to, our customers need to be able to do things like load device drivers, map to pins and peripherals, and sort of get a little bit closer and a little more control over the hardware than you might in a cloud environment. And then I don't know if multi-stage builds is worth a minute. Are folks familiar with multi-stage builds, which are part of the most recent version or two of Docker? Hugely beneficial for our use cases as well in terms of shrinking down the size of the basic structure. And then of course developer community. Like we can just draft off a lot of the great work and bring that to new use cases that's happening in the Docker community and continues to happen, of course. And then there's a whole bunch of things that we need to solve for that are unique to the use case. I think some of them have been referenced in things we've said, but also in your questions. Namely, and we'll show this, some of these in demo anyway, namely like Docker has, if you're familiar with Docker layers, so Docker's got a layer system by which you can, for a lot of your updates that you're applying, you can take just a single layer or a few layers rather than the whole image, which is marginally helpful, and it's really nice, I'm sure, in a cloud environment, but we've got customers on 2G networks with like 50 megabyte per month plans in very rural areas, and you can't ship, certainly can't ship a whole container. Definitely, you can't even ship like a layer. What we've built, what Petros and his team have built, is what we refer to as container deltas, which performs a comparison between the container version that's built and the one that's running. It does a full binary diff, and then sums just the differences down the line. So it can be, I don't know, like 50x or more bandwidth savings depending on the type of change you want to make. And then the container engine size, so we've like, I don't know what the stats are, but we trim it down a fair bit.
Yeah, so we had a big problem with that in the early days when we started with Docker 0.6. It was a single binary, quite small. And with the recent releases, it actually combined Docker with Docker D and Container D and Run C and all these binaries together. You go up to about 60-something megs, which is quite a lot for an embedded device when we're trying to shrink the space. So we do some modifications on how we build Docker and what features we ship there. And currently it's down to 27. So that's an important optimization we have to take into account when we Docker these kind of devices.
And then the last one here was the sort of, sorry, go ahead.
So why do you need Docker? Instead, can you just use run C?
Right, so the question is if we can use run C, and we could use run C for running the workload, but then there are other questions on how you bring down the container, how you store it on your disk, which is questions that Docker answers. So if we want to pull from a registry, the code to do that is in Docker. So we would have to write something custom there. If we wanted to store the layers and use overlay file systems, we would have to use something else to do that. With the Mobi project and where Container D is heading at, there is a possibility of using just Container D. They're going to add the registry integration and the graph driver integration there. So potentially go one level down and hopefully have the smaller binary with the same functionality. But currently we do need the whole stack to go for it.
There's also a little bit of a marketplace adoption angle on that, which is there's a tremendous amount of momentum building around Docker for these types of use cases. And invariably, a lot of folks are obviously running Docker in cloud environments, and there's this convergence happening, whereby you may have a workload that for some scenarios, some IoT scenarios may mostly be in the cloud, but other scenarios where you've got data residency requirements, network limitations, various other things, where you actually want to be able to move that workload out to the edge, and having some uniformity with Docker is really appealing to a lot of folks. So it's almost like the cloud's wagging the IoT a little bit in that regard. So it's just helpful to have something that people people know and love and are adopting more and more. And then the last bit, which we'll show you here in just a minute, is running Docker is one thing, but you also need to actually deliver software. You need to manage the devices at scale. You need to show their status. You need to allow people to solve kind of the full set of problems with building a product and taking it to market. I think we actually talked through these, so I'm going to be relatively brief unless folks have questions and just show you how some of this stuff works. We talked about container deltas. I think we said every word on this page, actually. I'm just going to keep going down. I think we said every word on this page. If folks have questions. This is maybe like a catch-all, and this is an important one sort of thematically, and it's embedded in all sorts of product decisions in the way in which we help customers implement, which is you fundamentally have to treat failure very, very differently. And I'm sure the kind of pets versus cattle metaphors maybe even getting a little tired at this point, but like our customers, they need to think about pets, right? And so that orientation around failure influences a lot of things with how we design the product and how our customers use the product. So a great example of that is update locking, right? So yep, container updates are fast and snappy, and there's just like very little downtime in between them. But if you're a 3D printer, let's say, who's in the middle of a print job, like that might be a bad time, let alone if you're an autonomous vehicle, which would be a horrendous time to apply that update. And so you need to have the devices be able to opt out of updates based on what the application is doing or based on a certain time of day. The ability to craft different deployment strategies if you have different requirements over downtime or available storage. I think a lot of folks know us from some of our kind of parlor trick demos, one of which was at DockerCon, like 2 years ago here, where we updated a drone while it was flying. I think not fully over the audience, but like it was close enough where I was a little bit nervous. And we swapped out the software and added, I think, thermal imaging software to it, because we could sort of orchestrate the application handover in such a way that it would have effectively zero downtime. I can't remember how many milliseconds it was, but it's enough to open a port, basically, right?
Less than hundreds.
Which feels like I said, feels kind of like a parlor trick, but like folks in a lot of industrial centers are like, oh yeah, about this upgrade, we need that. Like that's actually a real thing. All right, we'll show you what's happening with resin materials. I'm going to turn my back to you for a little bit and give you a sales engineer impersonation. Apologize for folks on this side of the room. I'll be descriptive if I can. So what you see here is...
Do you have a secure authentication mechanism?
So what do you mean by that question? Devices do authenticate with the cloud.
How do you know it's the device you think it is? It's not an impersonation.
Right, so that ties into the provisioning story and how each device gets a key that we then know about on the cloud side. So whenever there's some communication, these security credentials are exchanged. The way this happens is that at some point you get a device and you have to provision the operating system, and at that point the operating system you get from your dashboard will have security credentials and it's specialized for your user and for your application. So what you write on the device has the credentials required to come to the backend. And so that's how we know which one is which.
Resin provides a mini vault on the device.
So how you store the keys on the device is very dependent on the device. Most of our devices do not have a hardware encryption module or anything like that. So for those devices, we have to store it in this SD card. So if your threat model includes physical access, that's probably not a device for you. And we're starting to work with devices that do have hardware security modules, and it's in our roadmap to integrate with those and store the sensitive material in those stores.
But a key file will be generated on this, and it has to be stored somewhere on the device. So do you guys provide a vault for that?
Sorry, say that again.
It's just wrong.
So
Thank you.
the device, the data on the device, if you were to grab it and run with it, assuming you do not have a device that has hardware level encryption, the data is the data, right? That's a hardware limitation. With the way we've architected it, you can see the data that's on there, but you can't see anything else that's happening across the environment.
Okay.
and so if you had, if you could see that key sitting out there naked, it wouldn't be useful to you anyway. If that makes sense. Am I fact check me? Okay, cool. So we'll show you that provisioning step right now. So what you see in front of you is the resin UI. It's showing a fleet of 12 devices. If I were to pop over to the location tab, we'll see that some number of these are in Seattle, in our office up on Capitol Hill. The other 6 are in our office in London. I can show you those devices on some webcams. If I organize my windows well enough, I can. Okay, here we go. So these are those devices. We're showing them on webcams. They have to be Raspberry Pi 3s. You see 6 in London with the Big Ben Lego. You see 6 in Seattle with the Space Needle. It's just out of view, but we can have a little Space Needle over there. What I'm going to do is I'm going to recreate one of these devices here, provision it, and hand it to someone. So Pi 3, we've got a screen hat, which I'll put on this thing. And the step that I'm skipping, by the way, just in case people are curious, is to download Resin OS. So this button here, and I guess I'll kick it off, will download effectively a version of that software stack that we were showing earlier. And then we would just flash that to an SD card or onboard storage, depending on the type of device that you're working with, and then go from there. I'm going to skip all that because it's not that fun to watch. And I will take that SD card, which I previously installed. I hope this is the one. We'll find out soon. There we go. I will drop it in here. I've got a battery pack. And I need an assistant for this to pull the power later. Does anybody want it? Okay. So we'll plug this guy in. And then it's going to grab, you just do that, that's cool. You can go sit down, you can go wherever you want. So what's happening here is the device is powering up, obviously. It's going to check in for the Wi-Fi credentials on my hotspot, which are perfectly configurable. Well, actually, first it'll check for Ethernet. If it doesn't have that, it'll then look for the Wi-Fi. At some point, within the next 2 minutes, depending on the polling interval, that device will then check in. Again, assuming it got the credentials. We'll generate a unique ID, perform the handoff. It'll drop into this fleet of devices, and then it will check in to see, to check for updates. What I am then going to do is, while we're waiting for that to happen, I'll show you the deployment workflow that we're going to run through, and then we'll show you the deployment workflow, and then we'll see what happens. I'm going to make sure my hotspot is on while we're doing this. Okay. All right, so this is the deployment workflow itself that we're going to walk through. So, and this is, again, this is when we're pushing code. So on the left, we've got an end user. That's me. In the middle, we've got a set of cloud services that we run. I'm going to be very brief here so we can sort of get to it, but we hit a get endpoint. We perform a build that's going to properly emulate whatever chipset architecture I'm working on. It'll land in a registry. We'll perform that calculation to assess the differences between the two. The devices will then check in. They'll be told to check in through a one-to-many VPN service we run. They'll pull down the update, and then they're good to go. Before, during, and after, we show a bunch of data in the dashboard, various other places. I'm going to show you that. All right, so I see that there's something online, and you can see Hidden Snowflake is the newly provisioned device, which is checking in and pulling down an update. The way this is configured now, it'll actually pull down the full application. I could have preloaded that application if I wanted to. Subsequent updates will just have those bells. But while that's happening, we'll push some new code. These devices are running the world's simplest digital signage application. We're just going to go grab a different picture and then drop it in there. So I don't know if anyone has a favorite Safe for Work company logo or image. We'll do T-Mobile. T-Mobile. So I'm going to go search for T-Mobile logo. This looks like a pretty good shape. I'm going to save this image down to my desktop as T-Mo. And it reminded me there's a JPEG, I'm gonna need to remember that later. TiVo. Okay, and while that is downloading, I'm gonna show you what's happening behind the scenes in the code itself. So this is a repo, and I apologize, you won't be able to see this terribly well, but I'm just gonna jump to the most salient points. So again, I described this as being really simple. This is like the world's simplest Docker file. Do you want to talk through it?
Sure. So yeah, I mean, this is a simple Docker file. We're using a Raspbian-based image that we built for the Raspberry Pi. And the application will use the image magic and the frame buffer command to display the image onto the onboard frame buffer.
You're there.
Can you see it? Yeah. There used to be nothing. Right now we have this image.
Okay.
So I'm going to now drop out of here. And we're going to go make a change. So at the end of that, there was this kind of start.sh script. I'll now pop into that and we'll make some changes. All right, so you can see the script again is kind of similarly simple. We grab an image, we rotate it, we render it with that frame buffer application, we show it, done. Now what we can see is it's grabbing this image.png, which is not tmo.jpg. So what I'm going to do is actually go add this to my images folder. What was it, tmo.jpg? All right, so now it should be in here. Now it's in here. So now I'm going to pop back in here, and instead of image.png, we'll show tmo.jpg. Now the wrinkle I'm going to throw in here is, you know, we talked earlier about resiliency and how, like, if you can wield Docker on these types of devices, you get a bunch of stuff for free. So we're going to push some bad code to prevent this update from actually taking place successfully. And we will just, let's see. We'll just put exit 1. And then we'll maybe give it an interval of something, right? And then we'll show crashing, something like that, right? So this is basically just going to crash the container repeatedly. I'll hop out of here, I'll save it, and now this is one of the other nice things. Again, we talked earlier about being, you know, if we are successful, and I think this is a market level thing, if IoT is going to be a real thing, there's something like, I don't know, 10, 15, 20 million web, cloud, and mobile developers out in the world, and there's maybe, Brandon, how many thank you? Pressure to you. Like 500,000 like true embedded developers, right? People who have like the sharp folks, they got expertise in board support packages and device drivers, they got electronic engineering degrees, but there's only 500,000 of them, they're not growing very fast. So if we're gonna be successful, we need to allow, let's call it, folks that can deploy to AWS or Cloud Foundry, we need them to be able to be successful. So the steps here should allow me as an application developer, when I got some code to push, should be approachable, right? So this is, you know, adding, committing that code, and then pushing it up to resin. And this is going to kick off that process we were describing earlier, once I get the right password. This is going to kick off that process I was describing earlier where we hit the get endpoint associated with this application. We perform a build that's going to be ARM v7 for the Pi 3. We'll send it over to the registry, we'll calculate the delta. Charlie the unicorn tells me that that's been successful. In the middle of this download, sorry Henry, go ahead and pull that power cord. Just yank it out. Yeah, so now we've got half downloaded container sitting there. The rest of them will go ahead and successfully deploy this bad code.
You're going to press play of the, it's online.
Oh yeah. Okay, so the rest of these will merrily download. I guess what we now know is sort of is their bad code. At some point, we'll keep checking for about 2 minutes. At some point, that device will show up as online. Oh, actually, I screwed up. Actually, could you plug back in? I screwed up the sequence. We want that to get the bad code, and then we're going to pull it out when it's supposed to be good code. Sorry. So now what these things will do is once they're complete, They won't flip over to that T-Mobile image. What they will instead do, and I can check my work here by, let's find one that's fully complete. So London A1. If we look into the logs for this device, we can see that it's just constantly crashing, right? So behind the scenes, even though this device is online, I can see logs, I could hop in and troubleshoot. The container itself is continually crashing. So now what we want to do is hop in and fix that. And that's plugged back in now. Okay, sweet. So what I want to do is, we'll pull that actually when we're pushing the fix. So you get twice the amount of work, sorry about that. Now what we will do is we'll pop back in, we'll get rid of that bad code. And I think a lot of the folks here, we're going to go through that same process real quickly. For a lot of folks here, it's like, oh, okay, what's the big deal? This is like containers. We're used to having this level of resiliency. When we show this demo to people that have like grown up kind of building like hardware projects on bare metal, their minds are blown. Like, where did this come from, right? Like they're like skipping generations like forward to like modern, again, kind of virtualized like activities. So now the build is successful with, again, like what I was saying earlier, hopefully the right code. These things are downloading, they're downloading just the differences between the two. Now, they should all flip over. Oh, actually, Henry, pull that plug. Yeah, pull that plug now, sorry. Okay, so now when it's in the middle of downloading, these things will ideally flip over while staying online to that tmo.jpg logo. And it looks like some of them are just now starting that container start. So you can see the winner, oddly enough, was in London. I don't know why, which are funny. And you'll see they'll start to phase through. So again, like a pretty simple, very simple application. But for use cases out in the field, you can add as much complexity onto this as you want.
The size was different. Is that part of the mobile logo?
I don't know, I'm going to restart this one real quick, because I wonder if it's live.
I think it's just the shading of it.
Yeah.
Oh.
Yeah, it could be something with the, okay, there we go. We missed the updates, unfortunately. But you get the point. And again, they flip over while staying recoverable, except for this hidden snowflake, which at some point, we'll wait till it shows up as being offline, and then we'll plug it back in and we'll let it get its good code. That is pretty much it. Now, a customer that's pushing code in production is not going to just fire and forget, kind of cowboy style like this. They will invariably have a set of test devices, production environment, and then there's some sort of canary and phase rollouts across the fleet. But you get the point and see the workflow. Any questions on any of this so far?
How was it that you were starting a container while the other one was still running?
I mean, you can have multiple.
Well, they can have multiple containers, I guess. So in this example where you're just displaying an image, it's still displaying the one initial screen to the device. But when you're trying to start the other one, if it actually worked and you have bad code, then it's just going to take over and the other one will shut down.
Right, so the things that are happening in parallel are the download of the new version, and then in the default configuration, first we stop the old application and we start the new one. If you want it to run in parallel and do a zero downtime update, you do have to provide some coordination. Because if you're using the screen, yes, you have to pass.
So implementation specific,
Right. The default is download happen in parallel, and then we start the old one and start the new one, so you get that.
The other use case there is if you don't have enough onboard storage, you may have to choose a scenario by which you actually kill the prior container.
So when we talk about the devices at scale, does that mean you guys bootstrap the devices at runtime and just scale those out? Like let's say 6 of them are there right now and only 3 of them are running. So when you want to add another one which are pre-installed, are you guys gonna bootstrap the down 3 devices to come up?
Yeah, good question. So, yeah, and let me frame it hopefully correctly, which is, this is great, we're showing 12 and maybe 13, if we can plug that in whenever you want. Thanks. We're showing 12 devices here. What happens when you go from 12 to 12,000 effectively? How do you cover that process? What we will effectively do is we hand off an image version, a single image version, to our customers who will then take that out to the factory or wherever the devices are being produced. And then there will be technicians who will just flash that. And this is a common practice across any number of devices. And that's where the provisioning workflow becomes so important, because you got to be able to use that single image, but then securely provision 12,000 devices that will have limited scope only down to their individual devices, and then have unique IDs generated once they do provision.
Do you guys also do the on-air flashing? Like say you have a certain image running right now.
Yep.
But if you send a new image, maybe you can just flash it down to the.
Oh, you mean the firmware update, like of the full stack?
Yeah.
How do we do host OS updates?
Oh, how do we do hostess updates? So the way we do hostess updates in the same fashion happens. Okay, he's here. Has to do with the partition layout. So we do have 2 root partitions, and so when there is an update for the host operating system, we're gonna download and write a new version to the partition that's not currently in use, make sure that it's written, and then reboot and change the bootloader to point to the other partition.
Does that not have you? I mean, put you into limitations of the onboard memory?
If that does what?
I mean, so you essentially have the 2 partitions within your onboard devices, right? So, at some point of time, it might run out of memory, right, or space rather, that you guys are doing.
So for the root partitions, there are only 2, right? And we just flip between them. So it's not that we keep claiming space. Also, the root partition is read-only, so nothing gets written there. And everything that has to do with containers and user data, there's a separate partition that will span whatever is left on the device. If you have a 4 GB storage, we're going to use some space in the beginning for the host to work, and then the rest will be used for Docker and the user applications and everything else. And in there, of course, if you push a container that's 8 GB, it will not fit, and then you will have to solve that problem.
Can you replace a device and transfer the identity of the old device to the new one?
Oh, so if you had a hardware failure out in the field, but you want to return it to its prior state?
Sure, or you're upgrading, or whatever.
Yeah, so depending on how you want to implement that, so you might have a device that has some state on it, and you want to create another one. We don't currently sync any state from the device to the cloud, as you can say, oh, clone that device and give me whatever data it has, it's as one you want. We don't offer that right now, but we've definitely heard that need from some customers. So the best you can do right now is, like, if your device is using an SD card, take the SD card from one device and put it in another one, and that would allow you to keep the data on that device.
How do you guys manage the telemetry out of
Sorry, can you speak?
How do you guys manage the telemetries out of those devices?
So how you would get, for example, the state on the dashboard?
Yeah,
so it's not anything sophisticated. It's a standard HTTP API. So the device will do API calls to a backend.
Why is this guy offline?
Device checking to the cloud.
So the question is how often the device is checking with the cloud, and by default that's 1 minute. But you can configure it on a per device basis. So if you're running on a constraint, like if you're paying for 2G, maybe 1 too often, and you want to make it once per day. So that's a bigger.
Resetting my hotspot, we'll see if we can get it back online, but it's in the right state at least.
Another question, so how is the life cycle of the container process managed? Is it managed by the OS, is it managed by the resin container?
So the resin container is the one that manages the application lifecycle. So it's the one that will trigger the Docker pool, it's the one that will trigger the stopping the old container running the new container.
So is there like hooks for applications to know the lifecycle events? Or how do you people know?
So there are quite a few interactions between the application and the system beneath it. So the resin supervisor has an API that you can ask for, like if there's an update or the current status of the system. There's the thing Brian mentioned where an application in the middle of a critical operation can say, don't do any updates while I do this critical thing, and then say, execute the updates. There are a few interactions.
The other side of telemetry, real quick, just finish answering that, extended a little, is, again, anything that you can do in a container, you can do in resin. So we've got folks that have run like Datadog, Prometheus, any number of the other different tools that pull a tremendous amount of data out and run analytics. It's not the business we're in, but we integrate with a number of different options there.
Yeah, what's the footprint of resin?
So currently, I'd say about 600 megabytes is the disk space you need to allocate to have the dual root partition and the other partitions you need for this to work. We do have some things in the works that will take this number down. And in terms of memory, we don't run a lot of things. So we run Docker, which is also stripped down, and a few daemons for the network, and then the rest of the RAM is left for your application. Yeah.
So all the like Linux namespace like disabled or what's that count? Take root.
So as far as the kernel is concerned, all the namespaces and the C groups are enabled.
Then how the resin container knows the other container process namespace?
Right, I see. So the container that manages the other containers has some special privileges like access to the Docker socket. It's similar to, I don't know if you've seen how AWS, the ECS agent manages the Docker host, but it's a similar concept. The isolation of the application containers is a bit more tricky. So currently containers have to run as triplets. You have access, say, to GPIO or the frame buffer and things like that. And this is sort of legacy from the time where Docker had, like, you could either run fully containerized or with a privileged flag. Today we have a lot more options at our disposal. So there is some room of improvement there to have finer grained access, like privilege control of the application. But all the support from the kernel and the underlying systems.
Remember, you giving us a
Is this application used in any of the medical devices?
production medical devices today, nothing that is, nothing that falls under too much regulatory burden, just because we've been in market, I don't know, for 2 years effectively. But there's certainly some else. Nothing that's too close to the patient or patient data.
But this application can be used, for example, if I take Pascal API and connect it to get the images from the brain.
Yeah,
Can
so the scenarios, one example, I'll give you a company we were working with the other day actually, will have, they have to choose a Raspberry Pi, like everybody else, everybody starts with a Pi, generally speaking. And they'll have that sitting alongside a lot of the endoscopy equipment that has a whole bunch of video feeds around what's happening in a surgery, whether it's, you're scoping somebody's knee or like colonoscopy or whatever. And then they will run a lot of that data through the Pi. They will buffer it, they'll perform some amount of kind of image analysis on it, pretty lightweight for that device, although over time they can get to a bigger device and do a lot more of that locally. and then send that up to a cloud service where you can store and categorize and sort of, I think they create like highlight reels for those things, if you consider those highlights. But it's generally sort of, given the stage we're at, like we haven't been in market long enough for our customers to go through any of the really scary regulatory stuff. And we ask those types of customers, they should be using tech like this over time, but like it's still pretty early. So it's usually like stuff that's kind of on the periphery. Go ahead.
I had a question. Would you be able to run resin as part of the Linux distribution or another OS?
So we have made the resin stack run on Ubuntu. So you have the Ubuntu host and then you run the resin supervisor. And there are some requirements we have from the host, like having Docker and some other things. The drawback of going that way is the features you lose by not using resin-less. For example, I mentioned earlier, the hostess updates, for example, or the extra care we've taken to make the operating system read-only and maintain the state elsewhere. Very sort of things that might come up when we don't expect them, but it's doable.
Okay.
Question. First of all, it's super impressive. That's awesome. I'm coming from the world, and it's just neat to be able to see that. Did you say that you had more of a solution for the dumber devices? Obviously not going to run Linux on a light bulb or something like that, but something that can push out.
So for devices that cannot run Linux, like microcontrollers, the pattern we see a lot is where you have these devices connect to a local gateway via Zigbee, Bluetooth, some sort of radio technology, and then the gateway will either analyze data locally and then boost aggregates to the cloud or send out, I think, the cloud, something like that. So for that specific pattern, we do have support in resin, and essentially you can, the gateway does a local discovery of microcontrollers, like in the Zigbee spectrum, and they will register those devices back to resin so you can see them on your dashboard. And then when you want to push an update, you did push a container that will create the artifact, which is probably a binary image for the microcontroller, and resin will know that to update that microcontroller, that binary image has to go through the gateway that is currently managing it. So it will send that to the gateway, and there you have a small adapter that interacts with this system and completes the end of the chain. So we take care of getting the update all the way to your adapter, and then you do the last mile of sending to your microcontroller.
Can you use resin to do monitoring and then have it do alerts back to the server?
So currently we don't send back any sort of metrics apart from the application logs. So if you were to do CPU, if you want to do CPU monitoring or RUM, you would currently have to deploy a small daemon in your application and manage the whole thing yourself. Yeah, our general approach there is that we want to provide a basic level of service for that. Similarly to the logs, we're not a log collection service, so we'll show you the last date, but then we throw them away. So for that, we could also provide a service, a basic service, and if you wanted to do more, integrate that.
Are you looking at any partnerships with groups like the Open Fog Consortium?
I don't think we currently have, but it's certainly within our to go down that.
To create fog technology for offerings?
Well, I was referring mostly to the fact that for things that are not directly into our product, integrate with partners and say, oh, you want better logging, have an integration with a log company and say, now send all my device logs to there. So we integrate with those. So that's how we think about problems that are not directly on our.
It does actually bring up a side note, which is everything you've seen that runs on the device is open source Apache 2 license. enough of what's happening on the server side for someone to run a production fleet is also being open source. So over time, we could get involved with things like OpenBog and Open Connectivity Foundation and a handful of others. There's a few of them out there.
So, what are the performance differences of the resin OS that were flashed on the different types of devices? Are there any or
Differences in performance. I wouldn't say there's a performance difference of the same device with and without resin OS, because apart from the initialization phase, when the application starts, the resin part doesn't.
actually on the different devices?
Yeah, between different devices, you inherently get different performance, right? So if you have the Raspberry Pi 3, which is quad-core, and then the Raspberry Pi 1, which is a single core, you will inherently have better performance than the Raspberry Pi 3. We see some categorization, like if you want to do the GPU processing, a lot of people go to the NVIDIA devices. So yeah, I mean,
Hardware acceleration, there's some boards that support better hardware acceleration for
Yeah.
signage apps and stuff like that.
but
Everybody starts
there's
with
definitely
Pi.
different performance.
As a general note,
No,
but
I
then they
mean, like-
oftentimes graduate to things like the NVIDIA TX2.
Right. My following question was then, does that change you as an underlying stack, how you probably push the updates or do the updates? Because though, I mean, let's say the throughputs can be the difference between the different devices. So does that change your pushing the, I mean, process of pushing the updates, or does it affect in any way?
No, it's completely, so even if you have a really slow device, and actually even with the same device you can get wildly different performance, because you, like if you have two Raspberry Pis, or one is on a really slow or flaky network and one is on a really fast network, the one on the fast network will have the new version running a lot sooner than the one that's running on the flaky network. So you don't really need to have different devices to get into that situation, and we don't really consider that, we consider that part of just how the system works.
What are the constraints on the developer for building something for resin? Do they have to know that they're exclusively building something for resin?
So no, currently, I mean, apart from using the resin dashboard and the GPU workflow, the container environment is pretty standardized. So if your application can be containerized, it looks like it can run resin as well.
And who's your competition? We compete with the market.
Well, who's your limitation? A lot of companies that want to do these kind of things will provide some sort of DIY updater. There are some.
You'll see Canonical's got a snappy Ubuntu core, which has some tooling around it. I think I don't know how much they're going to invest in it, but they've talked about making that a full-fledged offering. We see a lot of folks who will take things like Ansible or Chef or Puppet and try to kind of port them over. A lot of DIY. We see USB sticks out in the field, like logging in by hand, like running a bunch of scripts, like really scary things that are like in the distant past. If you're kind of from the data center world, those things still happen out in the field.
The problem with this is that you can get something that kind of works relatively fast. So you get lured into that, oh, it's done now, but there it is.
I mean, you're clearly going after commercial market. I'm sure there's different vendors doing different things in open source. But from a commercial standpoint, are there other vendors who are going after this space?
For updates generally, I think there's probably a fair number, right? Both folks who've been around for a long time and like whatever you want to call it, over-the-air update or firmware update. For folks that are taking this particular approach, like I think we're with a formal product, I think we're the only ones really waving the Docker flag.
Yeah, the one that comes to mind, like an example is Mender that will handle the updates, but then to use that, you have to write yourself in this framework. So there are definitely some solutions. I haven't seen anything that does containers.
All right, so
Thanks for having us.
all right, great, thank you, guys. Appreciate it.